Welcome to Brain Vision.
We see that z is a function of x, and x is a function of r and theta. Okay, and z is also a function of y, and y is a function of r and theta. So to find the partial derivative of z with respect to r, we are going to use the chain rule. First, we'll take the partial derivative of z with respect to x, and we'll multiply this by the partial derivative of x with respect to r. And then we'll add this to the partial derivative of z with respect to y. And we'll multiply this by the partial derivative of y with respect to r. Similarly, to find partial z partial theta, we take the partial derivative of z with respect to x and multiply it by partial x partial theta. Then we add partial z partial y multiplied by partial y partial theta. Because we are not given the explicit function for z, we cannot find these two partial derivatives. However, we can find partial x partial theta, partial y partial theta, as well as the partial derivatives here with respect to r. So let's start by finding partial x partial r. So we're differentiating this expression with respect to r, and we get cosine theta. Okay, now let's find partial y partial r. We are differentiating this expression with respect to r, and we get sine theta. Now we will find partial x partial theta, and we get negative r times sine of theta. And finally, partial y partial theta, we get r cosine theta. So let's plug these in to our two equations here. We have partial z partial r is equal to partial z partial x times cosine theta plus partial z partial y times sine theta. Okay, and now we can find partial z partial theta. We have partial z partial x times negative r sine theta. So I'll put the negative sign here, and then we have r sine theta. And then we have partial z partial y times r cosine theta. Now for part B, let's consider the right-hand side of the equation. So that is partial z partial r squared plus 1 over r squared times partial z partial theta squared. And let's plug in our results. We have partial z partial x cosine theta plus partial z partial y sine theta, and this is going to be squared, plus 1 over r squared times negative partial z partial x r sine theta plus partial z partial y r cosine theta, and this will also be squared. Okay, so let's expand these. We get partial z partial x squared times cosine squared theta plus 2 times partial z partial x partial z partial y cosine theta sine theta plus partial z partial y squared times sine squared theta plus 1 over r squared. I'll actually put this on the next line, times partial z partial x squared r squared sine squared theta minus 2 times partial z partial x partial z partial y r squared sine theta cosine theta plus partial z partial y squared times r squared times cosine squared theta. And when we distribute this 1 over r squared, these factors of r squared go away. And now let's combine like terms. So we have partial z partial x squared multiplied by cosine squared theta plus sine squared theta. Okay, so I took care of these two terms here. And we see that these two terms, when combined, will cancel each other out. And finally, we can combine these two terms here. So we have plus partial z partial y squared times sine squared theta plus cosine squared theta. Okay, and cosine squared theta plus sine squared theta is just 1. So this is also 1. And let me make some space up here. We are left with partial z partial x squared plus partial z partial y squared. And this is the left-hand side of the equation in part B. So we have shown that the left-hand side and the right-hand side of the equation in part B are equal.